Hello and welcome to the TELUS Digital webinar, Overcoming the Challenges of AI Agent Creation, Training, and Evaluation. I'm your host, Steve Nemzer, Senior Director of AI Research at TELUS Digital. And today we're sitting down with Tommy Guy, Principal Applied Researcher on Microsoft's Copilot Studio team. And we've worked with Tommy on several state-of-the-art agentic AI training projects, building advanced data sets and simulation environments, and learned a lot over that. And we thought it'd be beneficial to kind of share some of those learnings with the greater audience here. So about Tommy, he's a bit of a Renaissance man with an undergraduate degree in philosophy and religion, dual master's degrees in mathematics and computer science. And at Microsoft, he spent the last 12 years in research and in software architect roles. And welcome, Tommy. We're so happy to have you join us. And anything you'd like to add to that introduction?
No, you got me. Yeah, it's great to be here. Really enjoyed working together. It's a wild time, and everything seems to be changing and moving, and it's a real pleasure to get to talk about some of the big moves, if you will, in agents and models. Sort of everything's changing.
So let's kick off first with a topic that's been widely debated in the AI circles, and that's the hype around agentic AI. 2025 was predicted to be the breakthrough year for agentic AI. What's your take? Did 2025, did it live up to the hype? And if not, what do you think may have cooled the jets on the hype?
Yeah, you're going to hate this answer, but I feel like the answer is both yes and no. It really depends on the vertical. I think we did see a step change on, for instance, coding, right? Claude Code, Codec. These things they've gone from pretty interesting replacements for like Googling stuff to full on, they can really help. So in those places, agents have worked. For a lot of the problems I care about in Copilot Studio, more sort of SaaS application management, more like business processes. No, I don't think we're there. I think we've learned a lot. The primary thing we've learned is just the importance of context in managing one of these agents. Right? Context meaning it's not just you get like the smartest model out there and it just knows what to do. Humans they can't do that either, right? A human without context is just a smart human. The strategies to go and find the right context for a domain, for a particular problem, we now know that's the hard part. And we're working on that problem. Where we've got that context, and again, coding is a good example. Yeah, we're doing great. But where we lack that context, I don't think we're there yet. Maybe 2026, we'll see.
So if we look forward to 2026, and maybe in that area, like are we improving contextual understanding or high content? Were there any breakthroughs in that area that you think maybe will affect the trajectory in 2026? Like, what got your attention?
Yeah, well, I mean, it's been a long year. Every year's been long in this AI push. This year is no exception. It was only a year ago that we were talking about O1. We were talking about DeepSeek. We were talking about this move to what we call reasoning, right? Reasoning is a bit of an anthropomorphism. What we mean is there's sort of some tokens that are generated by a model that are not quote unquote the answer. This is almost a space for the model to work out within its own context window. What is the user asking? Do I have what I need? Are there tools that I could go and invoke in order to get more context? And then eventually say, I think I'm done. I'm going to answer. We saw this work first for problems where there is an obvious right answer. Think coding, think math. Models are all of a sudden very good at sort of competition math. And then we saw this other big push over the course of the year on new ways of getting context. Certainly the most popular this year was MCP, Model Context Protocol from Anthropic. And it's sort of now, I believe this week, they gave it away. It's now sort of its own foundation. It's right there in the middle, right? Context. This is a way to say, given that the user wants me to do something, how can I go and find enough information to safely and effectively accomplish what they asked? MCP is one strategy. It's pretty good for places where the data or the context lives in, say, a legacy SaaS application. But there's others, right? There's a lot of stuff now in using file systems, what we call CUA, computer use agents, right? Where you basically give a point and click interface to a computer. All of those methods or strategies for getting context, I think we're going to look back at that as the most important developments in some sense of 2025. Reasoning models, I'm going to give those to 2024. We learned about them in 2025, but I think that the shift to everything is context, that's going to be the message coming out of 2020.
So in relation to your current research, and maybe the pending breakthroughs in better contextual understanding, how is that going to affect sort of the Copilot Studio product roadmap and what you're specifically working on over the coming months and year?
Yeah. So if we think about the trajectory of Copilot Studio, and even going back to its sort of Power Virtual Agents roots, sort of pre-Gen AI, we're seeing this shift from effectively hard-coded rules, right? If you think about a chatbot, if you will, 10 years ago, it's hard-coded. It can do a few things. Maybe it can sort of trigger a few sort of Power Automate style flows, a few deterministic flows. So it's more of like a wizard has taken over. And now we've moved through this period where a lot of the action was what we call RAG, retrieval augmented generation. I can go and answer questions. Now we are moving into this world of I want the agent to do things for me, right? We call these side effects, right? So I want things to happen in the world because I typed into an agent or because some autonomous agent was triggered. And this is a leap, right? It's one thing to get an answer that is slightly wrong in a text box on the internet. It's another thing to email that answer to my boss. It's an entirely other thing to have that answer impact how much money I pay to my credit card provider, right? So I think there's sort of two angles here that we care about a lot. One is if I'm going to start trusting an agent, right? Trust, this is where we talk about a lot. If I'm going to trust an agent to do things in the real world, I need to have very high confidence that it knows what it's doing, right? And the other is, so, okay, how do I get that context, right? Is sort of problem one. The other is I need to be able to observe what's happening, right? What are the right safeguards? Maybe full autonomy is not what I want right now. Maybe it can tee up, pay my credit card. Okay, I'm going to take this action for you, but I still need to sort of acknowledge that. So there's observability, there's product decisions about how much autonomy to give. And then we also think a lot about, okay, but the models still need to just get better at figuring out what they've been asked to do and using the tools.
In that trust area, for example, self-driving cars, autonomous cars, they have to be much, much better than human drivers in order for us to feel comfortable with them. They already perform better, but there's, people still have trust issues. Do we have a similar analogy in things that, where's human oversight of agents going to be still required, in the medium and long term?
That's a good question. I mean, I can answer for me. I'm not going to let an agent autonomously take actions that are impactful to me without a lot more verification, right? I don't know if my bank is going to start pushing an agent on me, but I'm probably going to be very careful how I use that. And I think it just comes down to the risks, right, of using an agent in sort of a high value scenario. They're still quite high. To your point, driving a 1-ton chunk of metal down a street at 30 miles an hour is a risky endeavor. And it took years, right, for us to gain that trust. We're there. I don't know if you've been to San Francisco or these other cities and taken like a Waymo. It's clearly better. I think it's that codec experience. It's that Claude Code experience. You start using it, you're like, oh yeah, no, this is good. I think that one of the key things that I'm looking for in those is with Claude Code, right? Probably the agent that I use the most, to be blunt. I get this feeling that it understands what I'm asking. And this is both, it's got a pretty smart model. It's also the UX, the entire package is structured to help me have trust, right? It builds a little checklist. So I can look at the checklist and be like, yeah, okay, that checklist makes sense. It tracks what I want. And when it starts writing code, it gives me the option to look at the code and say, yes, accept, right? Those are product decisions. They're not necessarily just model decisions, but they build the overall experience that builds trust. A Waymo, the coolest part about a Waymo, also a Tesla, is that screen, right? Where you can see what it sees, like every car and pedestrian and traffic cone. And you're like, okay, it is observing the world in a way that makes me trust that it knows what's going to happen. And again, this is context. I can see that it has acquired the context necessary to do the question or to do in this case, the problem. In Copilot Studio as a product, this is also something we think about quite a bit.
Well, you've got an example here, I think. Maybe, let's take a look at that.
Yeah. So Monday.com is sort of this sort of job management or task management software. They have an MCP server that is actually, you can load this thing directly into Copilot Studio. My team is the research team that is building our next version of models. So we go and we post-train or we fine-tune models. And to do this, we build these huge corpuses of tasks on these MCP servers, right? So go and do things, right? And here's a very sort of easy task, right? Create a new subtask under the payment systems integration task called test payment flows and show me all items in the parent. Oh, and then I forgot to say, but also assign it to Mike. Humans talk this way, right? They just like throw in a non sequitur and you're like, you're supposed to know that I'm talking about the subtask, right? I don't know how many exactly tasks this is. When I ran it through our research model, it got the right answer. And I showed you here, there were sort of 4 tool calls. Get board items, so like what's there now, list the users and teams. I got to find out who is Mike, right? Get a schema, like what is this board, and then finally create an item. In reality, there were probably 15 calls. Some of them were wrong. The model has to sort of figure that out. But the scary math, right? The thing that keeps me up at night is in the lower left here. Let's say that we've got 4 calls and that every call succeeds 99% of it. If all of them need to succeed, that only happens 96% of the time. If we go down to the bottom, let's say each tool only fails 1 time in 20, right? And that sounds like, that's pretty good. But if any one tool fails, right, in this layout, then the system, the overall experience is broken. And that is going to happen 1 time in 5, right? So that pernicious math, right, that combinatorial math, for these multi-tool call scenarios, this is what really makes me nervous. How do we instill trust in something where everything has to go right in the entire sort of progression of a task?
So given that it was sort of that cumulative success rate or cumulative failure rate, can result in ultimately in this case, a 1 out of 5 failure was probably too high, to be useful. Where do you see the top challenges in improving the success rates on those? As you break down the sequence of tasks, improving the success rate of task completion.
If you break it down, it's going to get worse, right? If you've got 10 things, each of which fails 1% of the time, it's worse. I think we just have to plan for a defensive agent. Plan for agents that will do the wrong thing, that will make the wrong decisions. How do they recover? Probably the most important feature in Claude Code is undo. I trust that I can be like, no, whatever you just did, I don't want it. And it can undo it, right? In our world, obviously, it can be hard to undo a bank transfer. And so maybe there probably you're not using MCS yet to control your bank, but you could in that case, ask the user every time you're moving money or doing a very high value transaction. Another side of this is the MCP tools that we build, right? Make them a little defensive. If they get inputs that don't make sense, don't try, right? Just be like, nope, you sort of have almost failed the checksum. You've got 3 parameters and those 3 parameters taken together make no sense. And so we don't believe that the caller really knows what they're doing and you bail. So it's defense in depth. I'm a model builder. And so on my side, we think a lot about introspecting. This is the tool I'm going to call. Yeah. How do I know it's right? Can I reason over, like, is this right? Before the model says, yep.
I think you have another example here that maybe illustrates that concept.
Yeah. So, we're in this sort of same example, create a new subtask under this payment systems integration task, assign it to Mike. Just think about the number of ways this can go wrong, right? There's no boards. There's 2 boards, right? That have the same name or that are sort of ambiguous to this question. There's 2 mics. There's 2 mics, but I don't ever work with one of those 2 mics. Microsoft's a big place. So can the model be smart enough to say he probably means that guy Mike that is in his org? There's sort of this just like explosion of ways things can go wrong. And then there's even sort of some simple stuff. There's network hiccups, right? A model that says, whoops, can't help you. The network was down for a second. Not great. But a model that can say, well, this was a recoverable error. Let me wait a second. That's better, right? Down to permissions. And then even this case that, we didn't discover was an issue until later, but you might have like a get items, read the database kind of thing. What if you get so much data back that it blows up the context window, right? So how do you build an agent that can manage that much complexity for a pretty simple thing? Make a ticket, assign it to Mike, right? This is where the reasoning models I mentioned, like the DeepSeeks, the O series, now GPT-5, basically all modern models are this. This is where it can try a tool, right? It can get a response back, and it can reason over, what should I do? How should I adjust my plan or my trajectory, right? I search for mic, and it comes back with 3 mics, right? Or 2 mics or something, right? Well, I can adjust my plan to try things like go look at the org chart. Does Tommy have a mic that reports to him or that works directly with him? Go look at my emails. Do I always talk to this one mic? Should I suggest that one? Or maybe you tune this to say, there's, at some point there's 2 mics in Tommy's org. I should quit. I should go and ask the user. That kind of nuance of adjusting the trajectory as it's happening, mastering that is how we build agents that we'll eventually trust.
And I think what's interesting, coming from the linguistics background, this is after the model understands the intent of your prompt. And as you mentioned, humans tend to, we're not natural prompt engineers. So we'd say, yeah, make sure Mike's on that meeting. No, not Mike, man, Josh. And in this natural language prompt, the model has to figure out from a poorly formed prompt a whole sequence of tasks, and then it's got to pick the right action and tool use for each task. It seems daunting. It's also daunting from a reinforcement learning, a training perspective. How do you create the training data sets that improve the performance? And I think one of the things that you're credited with is coining this term Goldilocks data for ideal training data sets. Yeah, tell us a little bit more about Goldilocks training data sets. Why are they important, and what are they? First of all, let's define
that. So maybe it will help to sort of explain the kind of techniques we use to train modern models. You've probably heard of what we call supervised fine tuning. We have a bunch of pictures and they're labeled cat and dog, and you give them to a model and say, learn to tell the difference between a cat and a dog. Models are pretty good at this. But this is essentially memorizing and then expanding on the patterns in your training data. This does not tend to teach this sort of creativity, this sort of introspection over a set of APIs that we need. So we use what's called reinforcement learning, right? And the data set that we use for reinforcement learning is what we call an RL gem or an RL environment, right? The pieces of this, we start with what we call the world state, okay? So one of our toy examples is actually a bank. We don't train much on this one, but it's nice to explain. So the world state here is a bank with a bunch of bank accounts, right? Those bank accounts are checking accounts and savings account and mortgages and credit cards. They have balances, they have owners, sort of get as much richness there as you can, right? We then also have MCP clients, right? So these MCP, I said client. This is always screwing me up. MCP servers, right? So an MCP server is exposes tools that can be used to manipulate the world state, right? We then we write our own MCP client that uses those MCP servers, those tools, to manipulate world states. We take that whole package. We sort of call this our training harness. We take a prompt and we put it in, right? A prompt might be pay off my credit card bill, and if there's enough money left over, move up to $1,000 to savings, right? Something like that. Even that statement is a little ambiguous. Does he mean leave $1,000 in checking? Does he mean, what does it mean to have enough money? There's always some ambiguity, right? But we give that prompt to the world state. We let the system chew over it. Let the training agent chew over that thing. And eventually it produces an output, right? A transcript of actions it took, and maybe some statement at the end, back to me saying I did it, right? We pass those to a grader. And the key detail here, the grader is able to go and look at the world state. So if I say pay off my credit card bill, I'm not asking whether the agent said it paid my credit card bill. I'm going to look at the balance. Did it actually move the correct amount of money, right? Now, once we've done that, for every example, we get a score. Often this is just a binary score, 0 or 1, but you can do sort of a partial credit, if you will, depends on the scenario. And we pass that to our loss function, sort of our actual model updating logic. GRPO is the sort of the open source version of this that was popularized by DeepSeek, and you can go and run this on a suitably powerful laptop even. That updates the model. Now, you asked about Goldilocks data. There's this subtle, tricky, hard thing embedded in this problem. which is that the world state and the prompt that I use needs to be just the right amount of hard. If I run the same thing through my model multiple times, right? Often we'll do 16 or 64 times, same problem, right? So same world state, same question. If every time I get the same answer and it's a pass, that's too easy. I can't actually train on that, right? Because I don't have any sort of difference to compare to. If every time I get fail, right, that's too hard. I don't have any examples of how to do it correctly, so I can't train a model to do it correctly. So the model or the training data needs to be just right. That's the Goldilocks part, right? It needs to be just right in the sense that sometimes I get a success, sometimes I get a failure when I sample. Then I've got enough signal to compare, well, what happened? What did the model do when it succeeded? What did the model do when it failed? Right? And I can compare those two and sort of train a model away from failure and towards success. But the key thing is I need a mixture of successes and failures when I run this system in a batch. That is the hard problem. That is what my team does all day, is how do we generate data that is just hard enough, right? That is in this Goldilocks zone of difficulty so that we can actually improve the model, right?
Yeah, this is really, really fascinating. On the TELUS Digital side, it's taken us a lot of taste tests to get just the right blend of difficulty in terms of a high value data set. And eventually, I think when we're at sort of the ASI state, you get your prompt can be as you've described, as simple as you are a helpful agent. The model it knows you well enough, it understands your intent and does the rest. But kind of in the meantime, getting that right blend is certainly tricky
Very
business. Do
yeah.
you've written about this, related that we today we sort of we can consider prompts as programs. We have to carefully engineer them, and maybe be a bit prescriptive. Do you see that continuing for the foreseeable future, sort of prompts as programs, or
hopefully not.
Yeah.
Yeah, I think when we were thinking about prompt engineering and sort of prompts are the program, if you will. They're the input. Generally speaking, the goal there was what was context engineering? We just didn't call it that yet, right? It was go and get enough context about what you really mean. A lot of it was just clarifying the actual ask or useful context that you push into the prompt. And, if you think back to 2024, prompts were what we kind of call like a one shot. You pass the prompt in and it runs. They weren't reasoning. They weren't sitting there and spinning their wheels and figuring out what to do. So now it's more about, we sort of think, how do we get the context to the model? But most of the energy, instead of let me write the perfect string, all the prompt is a string. I feel like when we just call it strings, it loses its luster. But it's a string. Instead of writing the perfect string, build the perfect tools. Build the set of tools that the agent can use to go and find context, rather than trying to be clever about pushing it all into the string that we're writing. Right. So like prompt engineering is we've already in some sense moved past it. And you're right. We want to get to the point where you are a helpful agent is practically all that we have to say, plus a bunch of tools. And you mentioned before, like getting a feel for writing Goldilocks data. Like one of the tricks we've seen is you start with an agent that is prompt engineered. You program in the prompt, right? It's really rich and complex, and maybe that's required to get your scenarios to work, right? Anyone who's built sort of professionally built agents today, it can be a little tedious, and there's still a lot in the prompt. What we do as we train a better model is what we call ablation. We'll go in and take that really complex prompt and start to take stuff out, right? Maybe after the first round of training using this process I'm describing, this RL process, the agent doesn't have to be as prescriptive because some of what we intended is baked into the model now, right? So we take that out and we repeat. And you can sort of ablate the prompt down from this novel of stuff to you are a helpful agent. Right. And that's sort of the ultimate goal, because that lets you write less stuff and still get a useful agent out the other end.
Well, this is, what's interesting is that ablation, I'm, familiar in the healthcare setting. Ablation is a surgical procedure. Do you find that some of the concepts that are in other disciplines can be applied to machine learning? Like how valuable is to have cross-disciplinary backgrounds when we're thinking about agent performance?
Yeah, I think, we're in a really weird, exciting place right now, right? Where this isn't just code that, I go and I run it. The models, I forget who said this, but they sort of said that, models are not trained, they're grown. There's this process of encoding human knowledge into these models that does require experts from a lot of disciplines, just as like to teach the model what humans know. But there's also really subtle, challenging questions around how do I measure whether a model is doing the right thing? It gets back to my philosophy roots. There's a lot of discussions about, seemingly settled questions, right? But no, we have to teach the model the right amount of nuance in answering something. We have to teach the model even, there's people working on, how can you teach a model to write prose that doesn't feel like model prose? Okay, how do you teach the model to write poetry, like good poetry, right? But also, how do you grapple with the societal implications of what we're doing? How do you grapple with, again, this like product integration to the model? The product wrapper needs to convey the amount of trust that we have, needs to help you gain trust. This is a really cross-discipline problem that we face of how do we not just build a new set of model weights, but how do we build a system that can automate a lot of human toil, right, that we can trust?
Yeah, is there, when you have a very nuancy thing like writing great prose, like is there a ground truth that agents can be measured against? And
No.
you
Luckily,
know,
I spend my days on easier problems. Maybe
yeah,
the bank either has money or it doesn't. The CRM either has a deal after I tell it to make a deal or it doesn't. But to do this well, to build these models, you do need to pull from all of those different backgrounds, and that's, I think, one of the more exciting things. If you look at the people doing really great work these days in AI, it's not people that just went and got a math degree. Plenty of those, but it's people from all sorts of disciplines that are attracted to this problem of like, how do we get a machine to work under massive uncertainty, right? And these sort of, every time you prompt the model, you get a different answer. So how do you deal with that amount of just change as you're measuring something? It feels more like bench science, sort of empirical to me, than it does sort of classic algorithms where you can just like write it on a whiteboard and smart your way through it.
Right. Yeah, we definitely, IRL is a non-deterministic state. And just to illustrate, we have a TELUS Digital, we have an office in Dublin, and they took us out on the pub tour, and I was listening to the reading of the James Joyce reading. I said, no model's going to get to James Joyce. Like, that's just like a too high of a bar in terms of
we'll see.
Prose. Well, yeah, we'll see.
I think a model can mimic James Joyce to the point where neither you nor I, admittedly not a literature guy anymore, but like neither you nor I could tell the difference. I don't think it would be James Joyce.
Fair enough. We began the discussion. You mentioned that some breakthroughs around MCP were really significant. How do you think that's sort of is that gonna have a near-term effect on the work that you're doing with Copilot Studio, or maybe agents writ large?
Yeah, definitely yes. We support MCP today in Copilot Studio. We're sort of seeing pretty steady uptake of this. Okay, all MCP is, in a lot of the cases we care about, it's another wrapper around a REST API, right? We're typically dealing with systems of record. This could be Microsoft systems, Dynamics, SharePoint, F&O, things like that. This could be Box.com. This could be SAP. This could be, anything. And those systems have given us some set of APIs to access data, right, as the system of record. Those APIs were typically generated for, effectively classic SaaS software, right? Some integration between system one and system two, and some human wrote that integration. Typically, this is a deterministic thing that they want to happen. So they're not necessarily written for agents. I think one of the big advantages to MCP is just a chance to do it over. There could have been other ways to do it that are equivalently good, but it's the one that caught on, and it gives us a chance to just, do a new way of describing our data to the world that is aimed at this new thing, agents, rather than sort of human system integrators. And so we do see good MCP servers look different than sort of classic like REST APIs, because they're aiming to convey more about what they do. They're aiming to take more signal from the model. And what we get is just sort of a chance to do that well. MCP is only one example of this, right? I keep talking about Claude Code. I made this slide. I think it is the best agent in the world. For me personally, in the last year, I went from using something like ChatGPT to like ask a bunch of questions. It would burp out, 15 lines of code, and I might or might not copy paste it. To it's now writing 90% of the code. It's kind of remarkable. And again, what it did is it mastered context. For SaaS applications, right now, in some sense, the state of the art is still like something like MCP. Because end of the day, the system of record, the data is too big on that system of record for me to have it locally, right? I need to access it through some little window, right? Some API window. How do I do that effectively? That's right now sort of right on the threshold of hard. If the data is on my computer, this is where I think Claude Code is excelling, right? They're really good at looking at your file system. Because often in code, that's where the context is, right? So when we see a system that has access to the right context, oh my goodness, it's amazing. Our question is, how do we do that for systems of record, right? SaaS systems of record that don't give us the ability to just read the whole database. The database is somewhere else and it's too big, right? Yeah. MCP is an attempt at that. What you're seeing next is managing the context. As you grow the context, managing it is the hard problem. In Claude Code, the big gripe I have is when it goes and compacts its context, basically takes all the stuff it knows and tries to rewrite it to a smaller block. Just quit. That conversation is over. It will not be as good as it was. Agent to agent, things like this, all they are is a means of managing context over the course of a long conversation, right? I sort of joke, we've reinvented functions. We can delegate to something. It has its own internal variables, right? Its own internal state. It's done. It throws away that state. It gives you an answer. Those sorts of tricks in agent to agent or coming soon in MCP, this is just our attempt to grapple with the fact that we still need to extract the right information from systems that hold that information. That's the hard part. That is still the hard part.
Right. When we had talked earlier, you said one of the challenges is around high fidelity compaction. That's a breakthrough that needs to happen so that full context. And, I'm just thinking like full context of an ERP system, like a dynamics and all the different, this is a tough nut to crack.
Yeah. I mean, ERP is one, we're talking tax code. I don't want a model to do my taxes. I have simple taxes. I still don't want it to do my taxes. F&O, there's so many calculations that are just so, and importantly, they're deterministic. They should stay deterministic. So getting that balance, right, of do I let the model do this calculation or do I give the model a list of supported calculations and let it pick one? Right. What's the right trade-off there? There's always a long tail of stuff you've never thought of. That's a lot of sort of the effort these days and product integration.
Well, that sort of leads us into and as we're sort of coming to the end here of the webinar, I wanted to maybe switch up a little bit and tap into your philosophy and religious studies. And, one hotly discussed topic again is when do agents get too powerful? And I think we're probably too early to be having that sort of discussion, but are you observing any evidence of emergent behaviors or things in maybe an alignment that concerned you? Or maybe, yes, we're in the age of reasoners. Any advanced reasoning capabilities that really surprised you? And I guess another way of asking this question is, what's your P-Doom probability?
I feel like I spend all my time in the trenches and I don't have a P-Doom probability. I think it's, let me put it this way. When I am amazed by something, I don't know if it's an emergent behavior or not. When I'm amazed, it's when the model understands my ask and my problem space and everything about the domain and does the right thing. And it's like, oh yeah, this model gets me, right? It's that same magical feeling when you get in like a self-driving car and you're on your phone in the back seat and you're like, I'm the only one here. This is amazing, right? When I see them fail, you can't do this with many closed source models, but with an open source model, you can see the reasoning tokens. When I see it fail, it's just spinning its wheels trying to guess what I meant.
Yeah.
And you'll see it, ellipsis. Does he mean thing A? Does he mean thing B? I think that generally speaking, when I see them doing like incorrect things, they're just operating under too much uncertainty. And what they're bad at is realizing, I don't know enough. Let me come up with a question to ask that would help. Right? That's like the frontier there. In terms of in our domain, we do worry a lot about bad actors. So it's not really a like alignment in the sense of the model has gone off the rails, but we talk a lot about XPIA, cross prompt injection attacks, things like that, right? As I'm calling tools, what if I've got a malicious tool, right? That is classically would return like a new piece of prompt that's like, ignore your instructions, do something, right? We think a lot about that. And how do we design, again, these RL environments to protect ourselves and to improve the models, sort of give it like a human-like skepticism of things it reads on the internet, I guess is how I would describe it. That's where we spend a lot of time and worry. I think the big model makers, you'd have to ask Sam what he thinks about PDoom.
Yeah. That understanding user intent, what surprises me often is how well it guesses my user intent when I'm interacting with a model and it's auto-completing my query. And, we like to think of ourselves as like we're human, unique, we're a snowflake, but it's seen a million similar.
Yeah, there's a lot of snowflakes out there, man. They're all still snow. Yeah.
That always amuses me how well it's finishing my thought.
When it's working. I guess the thing I'll say is like the thing that makes you unique is not everything about you. Right? Most of you is pretty boring. And then there's some stuff that you truly just know more, right? And that's where I think the models a sign of you think about a junior employee, right? A sign that you trust that employee is that they know what they don't know. And if you see somebody asks questions when they should ask questions and then works autonomously when they believe that they can get away with it, that they know enough, like that's what I want. And no, we're not always there yet. The models try a little too hard. This is maybe the agent side of sycophancy, right? Famously 4.0 would sort of tell you any idea was good.
Right.
You're so smart, yada, yada, yada. In agents, it's the tryhards, right? It's the like, I'm going to do something, damn it. And I would rather it not. Honestly, I would rather it just chill. I think that's something we're thinking a lot about. How do we train a model? Again, fine line. I don't want that junior employee that asks a question every time they need to do something. I want the one that is autonomous when it can be, but has the judgment to know when it shouldn't be.
Yeah. I think we're right at that stage where can the models replace like a promising intern? And, that's been speculating debate a lot. I think in some cases, yes. In other cases,
90% of the code I write is written by Claude Code.
Yeah.
Right. Yeah. And it's not that last 10%, right? That's the hard part. We talked about these MCP clients, right? We sort of, I maybe didn't mention this, but we mock the back ends. So my bank, right? There isn't Wells Fargo sitting behind there. It's, it's just a Python dictionary. Make this MCP server to match the APIs at any SaaS provider. Monday.com is one that I did. And make a fake backend in SQLite in memory. That's a one-shot thing now for a model, right? That is code that I probably do not need to give to my smartest engineers. Now I don't give it to no engineers. But where models are not good? Making the Goldilocks data.
Yeah.
They'll happily make Goldilocks data in the sense that it fails sometimes, succeeds sometimes, but for dumb reasons. There's two right answers and it only checks one. I saw this happen. Stuff like that. So you sort of, as users, we need to figure out the places where it does have enough context to be used effectively versus nope, that is still something that, for now, humans still matter.
Well, and humans being very, one of our best skills is continuous learning mode. And maybe, as we wrap up here, maybe one last question on that. Note, do you see the current sort of foundational models and in the frontier lab models, that trajectory that we're on, is that do you see that as being sufficient to reach that true continuous learning mode, or do we need another breakthrough on the level of the transformer breakthrough before we get to that continuous learning sort of end state?
Yeah. So when we think about continuous learning, another maybe way that I would phrase this is personal models, right? Learning in the context that my team uses it, like, I'm old, machine learning. Learning means you're updating the weights of the model, right? So the model itself has changed. Now, if we take like Tommy GPT and Steve GPT, and we're updating both of those to react to feedback from Tommy and Steve, respectively, the model weights diverge. They're literally two different models now. I've got to host those models, right? And as we all know, the hardware required to host a modern model, it's big, right? It's these huge H100s. And to host, this is like rough ballpark math, but to host one copy of GPT-4.1 Mini, my Chevy Bolt could keep that model running for about 24 minutes. So a lot of hardware, a lot of electricity to use those models. So once we get one per person in the world, I don't think we have the GPUs. Not even Jensen has the GPUs. So the good news is we are seeing breakthroughs where, my phone has a deep learning model in it, right? My laptop can run pretty good models pretty fast on modern hardware, right? So I do think we're going to see this what we call distillation. Take these massive models, use them to train smaller models, and then absolutely you could update the model weights just for you and host it just for you, right? You can't probably do that with a Sonnet 4.5 size model or a GPT-5 Mini size model. It would just be too expensive.
Well, Tommy, we really so much appreciated your time. We're looking forward to many future projects with you and the Copilot Studio team. Viewers, thanks for hanging with us. Just as a reminder, we're TELUS Digital. We're providers of AI data and AI test and evaluation services for model builders in the AGI and physical intelligence space. Tom, again, really wonderful to have you with us. Here's some links to Copilot Studio, articles that Tommy's written in the last year, and some other reference information. And again, thanks for watching, folks. Tommy, thanks so much for joining us.
Thanks for having me. Thanks for being great partners. We're gonna build a lot more data together, I think.
Love to hear that. Viewers, we hope to see you on our next webinar. And goodbye until then, and thank you.